thank you for showing up on a Friday afternoon. I know it's the weekend. You're probably done with classes for the entire week. You're ready to go wherever you're going to go this week. What? Party? I don't know. The introduction, I always make a joke whenever people read it off. That's half my speech right there, gone. My history, what I've done. He ended with the Royal Customs. That was back when I was extra super cool. I was in a band, like not the marching band, but a real, where you go out and on a Friday night go and watch them play. I was the drummer in that thing for, I don't know, 4 or 5 years. Had a really pretty girlfriend. I worked with Red Bull energy drinks. By the way, this is Preston, one of our photographers, and that's Steven. He's one of our newest reporters at the station. So, when was your first day?
Last Wednesday.
Last Wednesday. So brand new, hot off the press. No pun intended. You're going to see him shortly on KIII. But Royal Customs, yeah, I was in this band. I was going to school. I just graduated, got a degree in communication from UTSA, and I literally did not know what I wanted to do. Whether I liked it, I was interested in it. I'd always been interested in it. I just didn't really know how to make a career out of it. I just thought that would be a cool hobby. If there's no way I'll ever, become Alan Holt, KIII TV, whatever. All right. So this is where I work. That's the studio. This is my domain right here, the green screen. There's another part of the studio you can't see. Back behind this wall, there's a big group of weather computers, and that's basically where I sit for 2 or 3 hours of the day, forecasting, making weather graphics, scratching my head, twiddling my thumbs, just kind of looking busy sometimes when it's really easy in the forecasting department. But right now, starting to transition into fall, so we'll start to get a little more action in terms of cold fronts. The tropics are still relatively active. We're not out of hurricane season yet. So, the weather can be busy at times. Part of my day, or my day in general, is not prototypical as far as scheduling goes. Who here went to bed after 3 o'clock in the morning last night? After 3, boom, boom, boom. Okay, so more than a handful of you went to bed after 3. On a typical morning, my first alarm, not talking about a fire, is 2:45 a.m. That's the first one that goes off. I got 2 of them. One of them's my snoozer, the other one's my second snoozer, but I snooze them, I don't know how many times, depends on how hard the forecast is going to be. But in general, I'll be at the station between 3 and 3:30 in the morning. So the news doesn't start till 5, and from that 3 to 3:30 window to 5, I'm literally pen to paper, like nonstop, looking at as many things as I can, building graphics, making the forecast, combing my hair. I come in shaved. I hate shaving. That's like the least favorite part of my day. Then we go on 5 to 7 o'clock in the morning. That's the easiest part of the day. I get to just talk about weather, drop the clicker on the ground, whatever, do silly things, just fun, it's easy. I get a little bit nervous every time, but I think that's a good thing. Keeps me on my toes. It doesn't let me be lax. So we do that. Then after that, we do these little like ABC cut-ins where Ginger Z will say, no, here's what's going on in your neck of the whatever. And then you see me pop up, and there I am, 30 seconds. So we do that till 9 o'clock. And then after that, I do things like this. I'll come out to different schools. Earlier this week, I was at Veterans Memorial. Next month, I'll be at TAMUCC. I do a lot of little things. We got an event this weekend. There's a lot of community service that goes into it. And then when I'm not busy with that, I like to play golf. And golfers? I heard a lot more laughs for the under the temperature comments. So I know some people like to do that. So today, I'm going to talk about just forecasting. How do you make a forecast? How many of you think that the weather guy or girl on TV just shows up to the studio and like 10 minutes before the news starts and everything's made for them and they just go on air and that's that? Does anybody think that? 1, 2, 3. So about the same as went to bed after 3 o'clock in the morning. Some people do that. There are some people out there in the TV world that'll go in, they'll just show up and they'll have a weather producer that makes all their graphics for them. They'll just go on and just kind of you the weather. And that's fine. That's the way they do it. But this is how I do it. Before I start these talks, I like to talk about what's going on right now. Just a little synopsis of what's going on weather-wise. I don't know if we have, I know you're a meteorology student. Any others? All geology basically in these classes right now? You can be interactive. Yes, no, maybe so. No? Okay. Anyway, this is high-resolution visible satellite imagery of the coastal bend, South Texas. This was at 12:30, so right before this talk. And right now we just have these little fuzzy-looking clouds. These are like cloud tops from storms that once were. So we have some decaying storms out in the Gulf and then up the coast a little bit. We have a lot of these little white things. Those are the fair weather cumulus clouds that we typically get when we're humid and hot, just little rising bubbles of air that go up and condense, and we get them a lot, right? You see them all the time, the little cotton ball clouds. Those are fair weather cumulus clouds. This is the national satellite look. You see the big cumulus field in Texas, the same type of clouds we have here extending all the way up to the Red River. This right here, the remnants of what was Julia. It's a tropical system that's been hanging out there for at least a week now, so that's been a kind of a nuisance over there in the Carolinas. And then over in the Rockies, this is Casper, Wyoming, by the way. That's where I used to get it on up there in Wyoming. So Casper, Wyoming. Thing about Casper, you know how we complain about the heat all the time? Up there it was the cold. Like we're talking 110 on the heat index here a lot of times. For a place like New England or Wyoming, they can't handle that. We're acclimated to the climate here. If it was like that up there, nope, it wouldn't happen. Like the apartments there have window units for their ACs. It's weird, right? But that's what they have. And maybe it was just because I was poor and that's where I lived. But Wyoming, the coldest temperature I ever had to talk about on live TV was 62 degrees below zero. That's cold. That's like you go outside, you take a deep breath, and it stings. It hurts you to breathe in, and it makes you cough. It's that cold. And if your fingers, nose are exposed to the elements out there, you can get frostbite between 18 and 30 minutes. Cold, okay? Anyway, that was Wyoming. We're not talking about that here, but this little comma-shaped feature, that's the thing that may bring us down a cold front early next week. And by cold front, I just mean a little drop in temperature and some rain. It's technically a cold front. I mean, we're not going to be talking about 50 degrees and clear skies and then 7 in the afternoon. That's not 70 in the afternoon. That's not what we're talking about. This is the surface map. This is just weather mumbo jumbo telling you high pressure, low pressure, fronts where you think it's going to rain, things like that. High pressure typically means, anyone? High pressure, high and dry. High, nice weather. The reason for that is the high pressure, it's pressure, more pressure, so you're sitting on the atmosphere, right? To need rain, you need lift and moisture, and the high pressure is typically dry and dense air. So a big high right here, kind of Mississippi River Valley, and there's the front, big area of low pressure in the front extending down into the desert southwest. That L over there in the Carolinas, that's the Julia mess over there. This is upper atmosphere winds. This is up in the jet stream, about 30,000 feet. That's why it's called the jet stream, because that's about where planes fly. It's just a kind of a offhand name for the 350 millibar level of the atmosphere. The atmosphere is broken down into levels based on millibar pressure. This one's 300 or 250, 300 millibars. And it means that there's really not a lot of pressure up there because you're at the top of the atmosphere. So you're not sitting down on a lot of air. This is the top layer, in effect, of the atmosphere that we look at to forecast. So I don't know if this looks like much to everybody, but there's a big trough ridge pattern. Is this boring? Okay, this is like behind. I would never ever show a map like this on TV, ever. I would just draw a line that says jet stream, and that would be that. But this is what I would look at to get that graphic built. High pressure, this is up higher, so it's not where the other map said in Arkansas. The upper atmosphere high is over Texas right now. And I feel like I'm like talking, hey, 65 here. That's a, kind of feel like that. Maybe I can do, is this one? How does this work? Oh, can everyone see that? Yeah. Okay. Now I feel lazy. But low pressure, that's the center of the low, big trough in the west, ridge in the east, and that's where it's very hot and that's where it's cold. The jet stream typically divides warm and cold air. That's like the first place you look to get an idea of what's going on. Typically, when you have the trough or the big dip in the upper level winds, that is where you're going to get the most active weather as well. This part of the jet stream where it's coming out of the trough, that's where most of the active weather is going to be. For our purposes, we are high and dry. We have like a lot of moisture in the atmosphere right now because this high is in a place that it's funneling in a lot of Gulf moisture. So we have all this moisture in our atmosphere. It's also really warm, so you get rising air, and some of that moisture then condenses, and you get the little stray showers that we talk about, all the time almost in the summer. Save that for later. Tropics, Carl and Lisa, both tropical storms, neither a threat here. It's just what's going on in the tropics. No threat in the Gulf of Mexico. This is kind of a funny thing, but for my job, it's super true. So talking about a 20% chance of rain, right? So say it rains, right? It rains and it's a 20% chance of rain. The two guys on the left over there are going to say, well, it's only a 20% chance of rain. Like the guy said it was not going to rain, 20% chance, and it's raining, right? You got 10 guys up there, 2 of them it's raining on, so you're getting 20%, right? And the other 8 people, why isn't it raining? They said 20% chance for rain. I mean, this guy, get him off. Like, what is he talking about? Right? So you cannot, this is honestly what it feels. I didn't make this graphic. This is one of our affiliates somewhere. I know that because I know the graphics that we run, but that is literally what it's like. Say, you hear or read a forecast that says 10%, 30%, 40%. What does that mean? I'm going to ask somebody, what does 20% chance of rain mean? Anybody want to take a stab? There's no wrong answer. It's a percent statistics. You can make statistics say whatever you want.
It means it's an 80% there won't.
Okay, 80% there won't. That's one interpretation. Anyone else?
20% of the area.
20% of the area? Okay, that's how I interpret it. It means to me and a lot of other meteorologists that if you have a 20% chance for rain, that 20% of your forecast area is going to get rain. So 100% chance of rain for 20% of your forecast area. Well then, as a consumer of this forecast, what is the forecast area? You might think it's my house and my route to school. Is that going to mean that your 20% of that route's going to get rain? Probably not. To a pilot, they cover a lot more ground. They might think 20% chance. I'm for sure going to get rain. On this trip. But 20% chance, and whenever you see percentages, just kind of take it with a grain of salt. Unless it's 100%, they're basically saying it's going to rain everywhere. I stay away from percentages for this reason because it's misleading. People can interpret it however they want. I like to use things like stray, isolated, scattered, and numerous. Really only 4 categories to get my point across. When you say a stray shower, you kind of get the idea. There's probably only going to be like 1 or 2 showers out there. Numerous showers, probably going to rain. So then this is kind of how I feel about it. It just depends on where you're at. You got the tall, lanky giraffe, he's up above the clouds and it's not raining, it's great up there, and you got your elephants below the clouds, raining. Just depends on where you're at. And this is something that happens, it blows my mind away. We'll be talking about like a shower. I'll just go on Facebook, there might be a shower in Odom or Taft. It's moving to the north, right? So we all know geography. Those 2 locations are north of Corpus Christi, right? So I'll draw an arrow and say where it's going, what cities are next for this shower to get hit. And inevitably, the first comment on Facebook, is it coming to my house? I don't know. Like, I really don't know. And I ask them, well, where's your house? And they'll say Corpus Christi. And I mean, a lot of times I'll just respond with the information's in the post. Like, okay? I mean, that's just me complaining about social media, but it goes back to the point that forecasting is oftentimes a lot about perspective. How do you perceive what you're reading? You know, you could perceive a 20% chance of rain as I'm probably going to get rain. It's all about how you perceive the information that you're given. And the way I like to try to approach it is to let you perceive exactly what I'm thinking. That's just how I approach giving a weather forecast. So when I go in, I think, okay, what are the 3 big things that I want someone to know after watching or reading or seeing a Facebook post about our weather? And it's not that there's a 20% chance of rain. I think big picture, and I kind of let you or guide you to the answer that I want you to have. The way we get weather data, weather balloons. Every National Weather Service office in the country, there's 122 of them. We have one here at the airport. We'll launch a weather balloon once in the morning and once in the afternoon. And that balloon will go up in the atmosphere until it pops. This is interesting. These weather balloons, you can't touch them with your hands because you have oil on them. So when it gets really thin and it gets really high, it'll pop like before it's ready, kind of prematurely. But every day, these things will go up in the atmosphere. They'll collect data, things like temperature, dew point, wind direction, moisture, just all these things that you can measure in the atmosphere. They'll go up as high as they can until they pop. And then all the data we get from these balloons will then get fed into the weather models that we use. So like the GFS, the European, the NAM, the RPM, the HRRR, we call it the HER, the WRF. I mean, there's so Canadian. There's all these weather models that we'll look at on a day-to-day basis to try to get the best idea and interpretation of the forecast. This thing right here is called the radio sonde. Just kidding. It's called the radio sonde. Actually in TV, like sometimes my boss will be shouting at someone and it's very similar to that, little distractions all the time. Side note. But weather balloon, that's a radio sonde. That's the tool that goes up and that they're messing with those 4 guys on the bottom there. It's on the bottom of the balloon, and that's the instrument that records all of the data. There are the offices. So basically, we're launching these balloons and plugging the data into weather models. But there's a big problem with this. Anyone want to take a guess on what it is? Time zone? Budget is, those things are like hundreds of dollars and they just pop and then fall back down to earth, but that's a different problem. So the atmosphere doesn't only exist where these balloons are, right? We're taking a measurement of the atmosphere for 122 locations. This is just the US, I mean other people do it too, but we're getting this data, we're plugging the data into the weather models, but what happens when there's a balloon here and then a balloon here and there's a front right here? I mean, what my point would be is, how does the weather balloon or weather model know what's going on where the balloons aren't? There's no way to know. So the weather models do something called an interpolate, meaning if it's 80 here and it's 70 there, then it has to be 75 in between. So the weather models will go and interpolate all of the missing links in the weather, balloon data collection field, and we then take that information and make a forecast on it. So if its interpolation is wrong, I mean, there's really no way that you can make a 100% guarantee accurate forecast on something without, knowing exactly what's going on in the weather balloons. And this is more so for longer range data or forecasts. Anything past 3 to 4 days, I call it PFM, pure magic. Forecast magic, pure forecast magic. I don't know what y'all are thinking, but pure forecast magic. You know, because I think of it like this. When you're making a forecast after 3 to 4 days, think about astronomy, right? You can hit the moon like every time with the telescope because if you're off a little bit, you're still going to hit it. That's 3 to 4 days and in. But say you're trying to go out to some distant star, right? Your distance becomes a lot bigger, and then your error gets bigger and bigger and bigger. Even though you're not off by a lot, that little error ends up getting, you know, amplified with distance and time. So that's kind of how I view long-range forecasting. You can get an idea, but if you hear someone say, hey, in 2 weeks we're going to get a front, I would definitely question something like that. This is what that data, that radiosonde, looks like in a graph. This is, does anyone know what this is called? What kind of, you can't answer this. What this is called? What graph this is, specifically on the left side? It's called a skew T log P. And basically it's showing you the temperature and dew point, things like instability, stability, wind direction. This is actually from this morning at 7 o'clock in the morning from the airport. That's our atmosphere in graphical form. That's the red line's the temperature, the green line's the dew point. This hashed line is our instability. It's called KIII. You've probably heard of it. Maybe you haven't. But that line, all those lines tell you at least a little bit of what's going on in the atmosphere. When I look at that, I see the red and green line close together, i.e. a lot of humidity. The temperature and dew point are buddies. You know, up there a little bit higher, you got a little dry air, dry layer of air, and that's what we call the cap. Does anyone know ever heard of that? The cap. It's basically what's keeping a lot of the storms from happening. We get these puffy cumulus clouds, right? But not all of them turn into storms or showers because of the cap. This right here keeps the storms from firing off a lot of times. Is this too in-depth? Again, I would never ever show this on television. I wouldn't show this to high schoolers or elementary schoolers either. Just figured, oh, I get to talk to college kids. Maybe I can, you know, talk a little bit more. The thing on the right is called a hodograph. It shows where that balloon went when it went up in the air. So a lot of times they'll be all over the place. This one really didn't do a whole lot. It kind of just sat very close to where you know, it got launched, and that's probably because of that high pressure system that's close to us. It didn't really let it go far away. So that's the data that we get from launching the weather balloon. These are the fundamental equations of meteorology. I can't solve them now. I had to solve them when I got my master's. I mean, it's just calculus like crazy. They all tell you something different, and these are the equations that these weather models will, you know, they'll say, okay, dew point this, and they come out with they spit out a solution, and it does it for thousands of these, you know. If my job was to go in there and solve these, I would solve, like, you would get nothing done. Like, you literally would get nothing done. So we have these computers that solve them for us, supercomputers, a lot of them in Colorado, and they do the heavy lifting. I just do the interpretation. Not because it's lunch, but this is how I think of the atmosphere. Okay? It's based on layers. Each layer is going to give you something different. You're not going to get the whole picture, right? Unless you like go all the way down, get your toast, whatever chip you like, and go to town on it. But it's silly, but I think it gets the point across that you can't just sit there and skim the top and then know what the entire, you know, platter, if you will, is offering you. You have to know what's at all layers of the atmosphere, and each layer, this would be my favorite layer. Not for any, I just like guacamole, but each layer is going to tell you something different in the atmosphere. So what I want to do is I'm going to literally do exactly what I do when I go into the studio. I picked a certain time frame and a certain weather model to show you what I would look for when I'm trying to make a forecast. And I picked, I believe, 2 or 3 in the morning on Tuesday morning, this coming Tuesday, because this is that front that we've been talking about. This is brand new data. I mean, this is the 6Z run. Weather models run 4 times a day, 0, 6, 12, and 18Z. Z is Zulu time. So basically right now we are subtracting 5 hours from the time. When we go into daylight saving, it'll be 6. So this one was at 9Z, so it's going to be early in the morning on Tuesday. This is when this is valid. So this is legit. This is like forecast, weather model, central. You can get this information. You can find it. You can just search like GFS weather model and you could easily look at it too. Interpretation of what you're looking at is what makes meteorologists different. So keep in mind this is Tuesday morning. This is 250 millibars. So this is the what level of the atmosphere? Jet stream, yeah. Jet stream level. This feature right here, this is the one that's over here right now. So you can't see this, but if I were looking at this, I would look at every day, like every time frame between now and here, and I've already looked, so I know that that's the same feature, but that upper atmosphere low is centered over the Great Lakes according to this weather model. There's another feature that's somewhat interesting, and it's an area of low pressure over the desert southwest, and that's called the cutoff low. That is detached from the main, you can see the main flow of the atmosphere, right? Kind of color-coded, that red, then it goes down to yellow here. That's like the jet stream. That's the main flow of the atmosphere. So you're coming along, if you're riding in a plane, you'd get great fuel mileage right here, and then it comes back out of the US. And sometimes planes will do that. Nice. All right. Sometimes planes will ride the jet stream. It's like going up to San Antonio when there's a huge southeast wind, right? You get really good gas mileage. Has anyone ever taken, no? It's true. I mean, then you come back down, you try to time it with the cold front, and it's like you didn't even go to San Antonio with gas. But, so that's the jet stream. That's the low. That's the cutoff low. And this is forecast data. You can look at this. This is what I'm looking at. And I'm trying to figure out right now, okay, where are the big features up high? Where's the cold air? Where's the, the big system? And it's this and this, as far as my eye goes. And this is important because this, at one point, was a part of this. Think of it like this. This big system up here gave birth to this one, just kind of spit it out, which is bad for us in terms of the strength of this cool front. We'll get to that. This is 500 millibars. This is the part of the atmosphere that I look at to find out where rising air is. So we need 2 things for rain, right? You need rising air, lift, same thing, and moisture. Because you can have all the rising air you want, and if there's no moisture to condense, it's not going to rain. Think of it like a dry sponge. If the sponge is dry and you squeeze it, a roach and maybe some dust will come out, right? But if it's wet, which a lot of times it is soaking wet here in Corpus Christi, sometimes all it takes is a little flick of the sponge and you get showers, which is what we're talking about today. That's like the kind of forecast we have today. What I'm looking for at this point within this map is like squeezing of the sponge, the big rain event. And what I see at this point is a lot of rain here and a lot of rain probably in here. This is called vorticity, what we're looking at. This is the feature that you look at 500 millibars. It's 18,000 feet up in the atmosphere, and it's basically air that's spinning counterclockwise. So what we're looking for is something called PVA. It's not a thing that you're afraid to make out with people in public. It's called positive vorticity. That's PDA. PDA. Okay, sorry, my jokes are bad. Just give me sympathy laughs from time to time. Positive vorticity advection. The rising air is where this thing is going, not where it is. So it's kind of misleading. You would have to look at the model in time to see where these things are going, but this is likely going to stay pretty stationary, so its rising air is going to stay associated with that. This one, though, is going to continue off north of New England, and its rising air is going to be right here. And this is important. I haven't connected these dots, but on the we're going to go down to the surface and look at the precipitation forecast for this model at this time. I bet there's going to be a lot of rain right here, and there's going to be something over here. And I actually know that there's going to be something over us. That's why I'm showing this. But vorticity, 500 millibars. Going down, going down. This is, I almost made another joke, but it was a song, that going down for real. This 700 millibars, this is at about 10,000 feet. This is looking at relative humidity. So this is where I'm looking for moisture. And this is basically showing us there's a lot of moisture associated with that big upper low over the Great Lakes. There's some moisture associated with the low that's over the desert Southwest. And this right here, there's also a lot of moisture in Texas. And that is building right now today. That's going to be building tomorrow and Sunday. This is Tuesday morning. So we're going to continue to get this flow in from the Gulf of Mexico that we just talked about. And it's going to continue to pump our atmosphere chock full of this tropical moisture. And I just basically filled in the gaps between today and this forecast model Tuesday morning, like 2 a.m. 850, looking for temperature advection, a little bit higher up than the surface. So this is about 5,000 feet up. And the reason I'm looking for temperature advection, meaning a change in temperature with space, is at this level is because a lot of times cold fronts will be vertically stacked, meaning a lot of cold air really up high in the atmosphere, and those are the ones that tend to be really strong. Those are the ones that are going to clear us out, you know, crystal clear blue, those days where you like get in your car and it shocks you. Those type of days where it's just so dry, it's super crisp outside. You're looking for a big change in temperature at this level. And for us, I'm not seeing that here. This is where we are. In fact, the winds are still out of the southeast, east to southeast. This is a product of that upper level low. You can see the wind circulating. Can you see that? And then you can see how much bigger and more powerful the one up in the Great Lakes is. So when I'm looking for temperature advection, I'm looking for, see the wind barbs, where cold air is moving into warm air. So there's probably a really strong front somewhere in here, a little bit weaker here, and then it gets kind of washed out in Texas. This is 5,000 feet off the ground. So at this point, I'm thinking, okay, yeah, I know that there's a front coming, but it's really not vertically stacked. There's not a whole lot of upper atmosphere backing or support with this front. Try not to get too excited about it. I made the mistake yesterday of getting too excited about it. It's the first one. It's the first one. It's like a first kiss or something. You like build it up to better than what it is. Anyway, temperatures. This is 2 meter temperature. This is at the surface. The weather model is saying 2 meter temperature, about the height, you know, of me, 2 meters, so where people live. And this is a better idea of what this model is saying is going to happen at the surface. So now you can see there's a little bit of a difference here with the winds. See how they're coming out of the north? The air is colder from where the winds are coming from. So, I mean, this is saying that a front's going to be in the area Tuesday night, you know, coming in. It's not going to be a strong one. The winds are not strong. There's not a really tight-knit temperature gradient. Sometimes I'll see these, and it'll be like red, which is 80, and then this green up here will be like in San Antonio. That would be a strong front. When you have a tight temperature gradient, meaning a big change in temperature over a short amount of space, that is a big change in temperature over a short amount of space. We call it a tight temperature gradient, and typically it means a strong front is laying in that area. So this one not really showing a huge front up here in the Great Lakes region, Midwest, but there is some cold air with that. This is in the morning, but it's 40 to 50 degrees up there. Here, not so much, right? It's like 70. This is Tuesday morning. This is the precip forecast. Remember we talked about where that rain was going to be a little bit to the right of center of that low? That's what it's showing. This is basically showing you where the front is in terms of precipitation outlook. And for us, it looks like there's going to be some rain Tuesday night, more likely Monday morning though. Not a whole lot of rain over in the desert southwest according to this model. So that's just what the rain outlook is. So what I did right there, that was, okay, I got to wrap it up because I want questions. That was one weather model for 1 hour of one day looking for one event. Okay, that's one. I look at, I mean, I have 7 days, right? You got to get to the 7-day forecast. You got to fill up. How do you don't just like look for one event and then just say, oh, 90 the rest of the time. No, I mean, maybe some people do, but I don't. I mean, we're looking at these, every layer of the atmosphere through the whole forecast period, top to bottom, and probably about 4 or 5 weather models. Some of them don't go out as far. Some of them only go out like 24 hours. Others go out 3 to 4 days, right in that PFM zone, and then others go out 7 days, 10 days, 12 days. So there's a lot to look at. This is just one of the models for a significant event for us. So another thing, it's called MOS. Any fishermen here? Fishermen, people that like to go boating. This is great for wind. This is my favorite thing to use for wind forecasting. This is given in, you can look this up, MOS, MOS, Model Output Statistics is what it's called. You can look it up and get this data. The wind is going to be, wind speed right here, this is given in knots. And this is the Z time and the date. So remember, 18Z, that's 1 o'clock our time right now. When we switch back, it'll be noon. So minus 5 hours, Z time. That's what these times are up here. And then it gives you the max high and low for the date. This is just going out. Look what it says Tuesday, Wednesday, mid 80s, upper 60s, low 70s. We haven't been in the 60s since May 19th. So, I mean, it's a front that's coming in. But the wind, yeah, I think that this wind, the wind speed here, is, I think it's the best measure on a day-to-day basis for getting an idea of what the wind is going to do. It also tells you the direction, but it's in, it's showing you in a cardinal direction. So 13 is out of the southeast. Make sense? You can look all this stuff up. Then, so I just did all that. This is, I just took a screenshot or a picture of the, the graphic that I built yesterday. Got to build all these graphics. This is probably what I spend most of my time on. All these things, it's like building an animated movie. Like everything that you see, this green shade, the fact that the green shade, this is just me being like weird, but I like to have it where it's not a clean edge, where it's just like shaded. I mean, I have to go in there and make it do that, right? So front, I draw it. There's that low way up in the Midwest, the little storms, whatever. I try to simplify it as much as I can, but still make it, scientific and accurate. So I do that. You got to time it all out. You have to pick your times. There's a pause point. There's like, oh, these will flash on, and it's just all this stuff for one graphic. This one probably took me maybe 20, 30 minutes to build, and it's a lot more. It like comes down, swoops in. The camera's like moving everywhere. It looks nicer than what it is right here, but I'll make these every day. This is probably one of my favorite things about the job is applying what I just kind of reasoned out on the weather models and then making it look neat through weather graphics. I'm not the best at it, but I like doing it. And then the last thing I want to talk about, phone apps, right? So everyone always says, well, my app says this, my app says that. My app said it's going to rain at 1 o'clock today. My app said it's going to be 90 on Monday, but you're saying there's a cold front coming in. Like, there's all these things that sources for weather information. And what I would say to someone that says, well, we don't need you. I'll just use my app. What I would say is, that's great. Like, I mean, honestly, that's great. Use the app. I would use my app on it. If I knew that the forecast was going to be just cut and dry, same thing day in, day out, the app's probably going to be pretty close, because what it does is it takes that MOS forecast, that model output statistics, and it says, here's your forecast. It just rips those numbers, puts them into the app, and that's what you get. There's no human interpretation. There's no explanation. There's no yeah, it's going to be 90 on Monday, but this front's coming in Monday afternoon. Like, it can be very misleading. So I would say great, use the apps. It's better to be weather aware, weather savvy. But if I were you, maybe if I wasn't you, I don't know, I would find some source for information, whether it be me, Dale Nelson, Bill Vesey, Sean Kelly. Really, I mean, I could care less if you like me or not. But actually, I care. I think it's just a good idea to maybe it's just me. I like knowing about the weather, and an app doesn't do it for me. So I would just kind of pay attention to what guys are saying, and you start to figure out who, you start to see trends within people and how they deliver forecasts and what they say, what they don't say, who gets excited about certain things, whatnot. Best radar app, I think, out there, Radar Scope. Anyone ever heard of that? That would be a good weather app to have. It's $10, but it's awesome. So there's 5-10 minutes left. We'll do questions. A lot of times the first graders will ask, why is the sky blue and how much money do you make and do you have a girlfriend? So we probably won't ask those, but it doesn't matter. Questions are good no matter what they are. Okay.
Yeah, I noticed that all the phone apps have about 25 advertisements for it about every minute.
Yeah, that's good. That app's making money. Yeah. But it's probably annoying as a user.
Now that drones are getting more and more popular for all sorts of applications, do you see drone usage for weather forecasting?
I don't know about weather forecasting, but I do know that, for example, if there's a tornado that goes through a city, drones are starting to be used to do the damage survey. And it's good for things like the flooding in Louisiana. I think it's more of a visual thing rather than putting an instrument on it and but that could certainly be a thing. And also, since we talked about damage survey, tornadoes can only be rated after they occur. Did you know that? So if a tornado's happening and you hear a guy say, oh, this is an EF3 tornado, and it's live real time, that's just not possible to know because tornadoes are rated based on the damage they produce. So in essence, you could have the strongest tornado ever, and if it went through a field and knocked over a hay bale, it would be rated an EF0. Okay, so it's based on damage that they produce. I don't know. But that's how they do the rankings of them.
What about like geographical trends? It's like in our area, it seems like we predominantly have high pressure around here. Like during the summertime, we stay dry a lot. Is that real, or is it like due to things like phenomena like El Nino or like stuff like that?
So high pressure. We always hear the blocking high. It's going to steer it here. It's going to steer it there. There oftentimes is a big area of high pressure. It's called the Bermuda High. It's over Bermuda, and that's really the big steering current for tropical systems. It can meander, closer to the U.S., farther into the Atlantic, and there's typically something set up right there, and that can keep us dry. It can also do what it's doing right now. We got the high pressure funneling in tropical moisture, and that's going to be one of the things that makes our rain chances go up. El Nino is a teleconnection, meaning that weather in one part of the world is affecting weather in another part of the world, and that one specifically focuses on the eastern Pacific sea surface temperatures, and it says when they're warmer than normal, we get an enhanced subtropical flow of moisture right into South Texas, and it tends to give us more clouds, more rain, and cooler than normal conditions because of said clouds and rain, not because we have these cold fronts. Anyway, that's brain dump on El Nino. But I don't put much stock into the dome effect of Corpus Christi. There's a dome here, why isn't the rain coming? Because then the very next morning we'll get a shower and someone will be complaining, well, you didn't say it was going to rain. It's just like, it's all about the perception of everything. More questions? Does everyone have a date or something? 2 o'clock or what?
So do you guys ever use like the Gibson Ridge technology?
Gibson Ridge, I'm not familiar with that.
It's like it's an extra kind of like a radar system that you can use in East and the other weather stations around.
Like a mobile radar
It's
station?
for laptop use.
I've never used it, no. I just use the WSR 88D Doppler radar that's over there at the airport. It's that golf ball looking thing. Ever see that? That's the radar. It's a good analogy, right? More questions? Any more questions? You got 5 more minutes here.
Why does the water temperature in the Gulf affect the strength of a storm that's coming in?
Okay, it's latent heat. He's talking about hurricanes, right? I'm assuming, yeah, tropical systems. Tropical systems need they need moisture to live. They're warm core systems. A lot of these, like the system that's up there in the Pacific Northwest, is a cold core system, meaning it's feeding on a temperature difference, cold and warm air, and that's what's making it spin. There's a lot of other stuff. But these hurricanes and tropical systems, they feed on warm water is basically their fuel source, and little to no wind shear, meaning the winds are pretty calm. The water gets pulled up, it's warm. Warmer water, warmer air has more energy, just, things bouncing. That's what temperature is. That meant like collision stuff. And the air evaporates, and then it condenses back into a liquid state up, in the hurricane. And there's a latent heat transfer that basically, it's called hidden heat, is basically what latent heat means. And when this water gets evaporated from the Gulf or whatever water source it is, and then it cools and then recondenses, you basically it's like a heat transfer. You get this huge store of warmth up there, and the storm just, it keeps going. I mean, tropics, that's basically my nutshell answer for what that would be. But the warmer the water, the more volatile the fuel is, so to speak. So yeah, colder water, you don't get that energy. 80 degrees, that's the magic threshold.
In your simplest terms, can you tell us how is a tornado formed?
Oh, okay,
and
tornado.
why is it that there are more tornadoes occurring or forming in the Midwest?
Okay, Midwest, Tornado Alley, it's flat. That's number one. Number two, we're talking geography right now. You have a funnel of mountains, basically. You got the Rocky Mountain West, you got the Appalachians. It's like a funnel. I wonder if I can... It's like a funnel of whatever you want to call it. Appalachians, Rockies, and you get these systems that come down in the spring from Canada, and it basically funnels right down into the Great Plains, the Tornado Alley area. So you get these disturbances. They have a lot of, remember that term, vorticity? A lot of spin up in the mid-levels of the atmosphere. There's a lot of wind shear. So we'll be seeing winds, a lot of moisture coming in from the Gulf of Mexico. Winds will be out of the south, southeast. And then as you get up higher, the winds will be coming in from off of the Rocky Mountains. So you have differing wind with height. That's how you get what's called helicity. It's basically a rotating tube of air that's up higher in the atmosphere. And remember that term, the cap we talked about, that dry layer of air? Well, that air that's coming off the Rockies tends to be really dry. So what you're doing is capping the atmosphere until the atmosphere can override the cap. And I guess a good analogy for this would be, a lot of times our storms are, I'm going to go cap here. Think about a soda, right? You shake it up with the cap on it, nothing happens, right? Until you take the cap off. Our atmosphere is like shaking a soda without a cap on it. You shake it and yeah, it's going to fizz out and you'll get these big tropical showers, a lot of rain. The cap for these storms up in the Midwest, they'll need something like a little piece of that vorticity to come through, or temperatures to reach what's called the convective temperature, meaning the temperature at which air will start to rise freely without some kind of trigger mechanism. So you need something like that to get these storms going, and you need the wind shear, and then after that, the actual tornado genesis itself is theory at this point. There's, I think, something called the Lemon, I can't remember it off the top of my head, but basically you need some kind of backing wind to go into the storm, which then pushes down these tubes of helicity, and then if and when these touch the surface, you get a tornado, and only if and when that tube touches the surface, and the way you know that is debris. If you see a funnel cloud and you don't see anything, on the ground, no cloud, anything, it's just a funnel cloud. Sorry, didn't know. I won't know every answer. More, I'm good. The longer I stay here, the later I get to be to work.
I know it's not really your study or like, is there a, do they now like living in like dry areas or more moist, like different areas of like affect or like any type of areas, like breathing wise or just like anything?
I would say, I think it's probably healthier to live in a humid area. I mean, you might not look as pretty with the greasy skin, but I know, got to, I powder it up before I go on, but it's probably healthier to live in a humid environment. When it's drier, you get, your skin, I'm thinking in terms of skin right now, but
I read a lot, so I think it's like breathing wise. I know whenever I go up to a place where it's dry, I get harder to breathe. I don't know if that's
yeah.
asking for something or
I don't know about the running thing. I know allergies can be a lot worse away from here. I think that probably has an effect on it. Like if you're living close to the hill country, something like that, you get a lot more stuff in San Antonio that doesn't really get down to here. So.
On a different topic, where did you go to school and how did you end up in the position where you are right now?
School, UTSA. Before that, anyone know Clark High School? San Antonio, Clam Cougars. That's where I went to high school. UTSA, got a communication degree. Really simple. It was like the most broad and kind of, I'm sorry if you're a communication major, just dumb thing to do in college. Not because it was bad to go to college, but because a communication degree, when it's not paired with something else more specific, is so broad, I think, it's just me talking, that someone else is going to have a more specialized degree in maybe the thing that you want to do. So for me, it just worked out where, okay, I have this communication degree, and then I went and paired it with a meteorology degree, and I think that's what elevated that's just my opinion. I'm not a school counselor, but that's the road I took. So Starkville, Mississippi, Mississippi State University, that was fun. That was a fun college town. I was in the band, I was all involved with it, and it was a really, really good experience. I recommend it. Mississippi State. More questions? Yep.
What was your thesis on? What did you graduate?
It was a non-thesis program. So what we had was something called comps. Yep, comps. And it was basically, if you don't pass this test, you don't get your degree, which is basically, what it was. So it was a non-thesis track. It was both a written and then a written exam. So basically whatever the professors wanted to ask. And if you passed that, you then went into a room. It would be like me sitting here and professor here. And what they do is they then ask you questions that they think that you're weak on. And if you can't answer them correctly enough, you literally do not get the degree. I mean, that's just the track that program was on. So it wasn't a thesis. There were some people that did thesis. What's the plural for thesis? It's like deer. All right. But yeah, there were some people that did it. I just chose to do the comprehensive route. Worked out.
Do you find that was a lot better for you?
I just didn't want to do a thesis. That's it. That's why I didn't do that. Yeah. I don't like research. I don't like doing it. I understand that we need it. Sorry if you looked at me like, still doing it, no? But anyway, but research is obviously how we learn things, but I like to just, like if I'm in a fight with my girlfriend, I don't like to sit there and analyze everything. I just want to come to the conclusion. That's, anyway, more questions.
So how much physics does it need in order to be able to understand, the model?
Physics?
Yeah.
I think that what happens is when you're looking at this, you intuitively understand what's going on within the weather model, if that makes sense. The physics, the math, I think that's all for the part where you're actually putting together a weather model. I don't go into work and say, oh, I wonder what the QG omega equation is going to be doing today. I just know that equation means, or the hypsometric equation, whatever. I know what they tell you, not necessarily going to go in and solve them every single day. It's just, that's how I look at it.
Somebody's doing it for you.
And then I'm interpreting. It's like Tom Brady, right? Tom Brady doesn't make a football. He just knows how to use it, and he's good at it. right? He does, yes, he knows how to deflate, but yeah.
Do you have any more questions for our guest speaker? Let's give it up for KIII.
Oh, okay.